So these are the 4 guided practice problems that I asked you to try. So if we look first at problem 5a, the problem is x to the 4th power plus 5x minus 6. And it asks you if you can write this using that quadratic form. Now the answer to that is going to be no. And the reason for that is that this would have to be a squared term so that I could factor that first term into a pair of x squareds. So no, that cannot be done using factored form of a quadratic problem. So now if we look at 5b, 5b is the problem 8x to the 4th plus 12x squared plus 18. Now the first thing I like to do is pull out that GCF. It just makes it a little bit easier to look at that problem. So if I look at all 3 terms, I see that GCF is going to be 2. So I'm going to pull that out. And that leaves me with 4x to the 4th plus 6x squared plus 9. Now you can see how we are utilizing that 4th degree, and that goes down to be half as 2 degree. So this actually can be modeled by that quadratic term. Now, if I try to factor this, it doesn't actually factor. This is going to be a prime polynomial, but it can still be modeled by a quadratic. So if we had to solve it, we could use that quadratic formula to do it. And we'll see that in example 6b as we move forward. But how I could actually write this in that quadratic form model, it would be 2x squared, and that would be our squared term, plus 3 times 2x squared plus 9. So you can see how we just square that first term, and it's modeled the same way. All right, now we're going to move on to problem 6a. 6a starts asking us to solve. So it gives us the problem 4x to the 4th power minus 8x squared plus 3, and they're asking us to solve. Now, I don't have a GCF there, so I'm looking to see, does it model? And it does appear to be modeling a quadratic. So I'm going to go ahead and factor it and treat it like a quadratic. So I'm going to split that 4x to the 4th into a pair of 2x squareds. And then I'm going to factor that 3. Now remembering that this is a plus and this is a minus, so these two signs have to be the same. And I've got to factor that 3 out. So there's only one way to factor that 3. Now before I solve, I'm going to go ahead and check to make sure my outers, which give me negative 6x squared, and my inners, which gives me negative 2x squared, adds together to give me that negative 8x squared, which it does. All right, now from here, I'm going to utilize the zero product property. Since I have my 2 factors that are completely factored, I can set those each equal to 0. So 2x squared minus 1 is equal to 0, and 2x squared minus 3 is equal to 0. So now we're going to go ahead and isolate. So I'll have 2x squared equals 1. We'll take that 2 to the other side, and we'll do a quick square root of both sides. So that's going to give me x is positive or negative square root of 1/2. Now later on when we talk about radicals, I'm going to show you how to simplify that. But for now, we'll just leave it in square root form. Now let's do the same to the other side. So we'll take that 3 to the right. We'll divide both sides by 2. And then we'll square root both sides. So that will give me x is equal, don't forget the plus or the minus, square root of 3/2. So you can see that our 4th degree equation resulted in 4 solutions. So I get x is equal to positive and negative square root of 1/2, and x equals positive and negative square root of 3/2. And those are our solutions, all real answers. All right, so let's try our last problem, which is 6b from the guided practice. And this problem is 8x to the fourth power plus 10x squared minus 12 is equal to 0. Now again, this guy's going to have a GCF of 2, so I'm going to go ahead and pull that GCF out right now. So that will leave me with 4x to the fourth plus 5x squared minus 6 is equal to 0. Now, what I can do so I don't have to mess with this guy later is I'm going to go ahead and divide both sides by 2. And 0 divided by 2 is 0. So that leaves me with just 4x to the fourth plus 5x squared minus 6 equals 0. Now, I can try to factor this, but I'm going to give you a little secret. It's not going to be factorable. So if I factor the 4x to the fourth into 2x squareds, there's only two ways I can factor that negative 6. I can put a 3 and a 2. I can put a 6 and a 1, but neither way will give me that positive 5 in the middle. So for that reason, this is going to be prime. So since it's not factorable, we're going to have to utilize another way to solve that. Now, since it is in that quadratic form mode, I'm going to use the quadratic formula to solve it, but I'm going to use it a little differently. Typically, if this were quadratic, where this term would be a 2 or to the degree of 2, I would start the quadratic formula with x is equal. But because this is a fourth powered equation, it's going to actually start off with x squared. It's going to have half of that. If that was a 6th power, this would be an x cubed is equal to. So we're going to start with x squared is equal to negative b. Now the rest of this is going to look the same. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. All right, now let's simplify. So again, this is not x equals, it's x squared equals negative 5 plus or minus the square root. If I take 25 minus 4 times negative 6, that gives me a positive 121 over 8. Now, the square root of 121 simply is 11. So that's going to give me x squared is equal to negative 5 plus or minus 11 over 8. Now I'm going to have to actually do this separately. So I'm going to have x squared is equal to negative 5 plus 11 divided by 8. And then I'll have x squared is equal to negative 5 minus 11 over 8. So to do this math pretty quickly, negative 5 plus 11 is going to give me 6 over 8, or that's going to reduce to 3/4. And then come down here, negative 5 minus 11 is going to give me negative 16 over 8, which is negative 2. Now it looks to be like I'm done, but I'm not quite there yet. So now I have to square root that because x squared is equal to 3/4. So I'm going to have to square root both sides. So x is going to equal positive or negative. Now I can pull out that 4, so I'll leave this as x equals positive or negative square root of 3 over 2. And down here I'm going to have x is equal to positive or negative square root of negative 2, which don't forget we've got to pull out that I. So I square roots of 2. So 4 answers on this problem. Our 4 answers are going to be positive and negative square root of 3 over 2 in addition to positive and negative I square roots of 2. So you can see that I have 2 real answers that are rational, that are irrational, and 2 imaginary solutions. And those are our guided practice problems. We'll look for some more practice tomorrow.